Okay, so for the next whatever time it is, yeah, that was 15 minutes. So next like 15, 30 minutes, let's have a chat about this. If you have any questions, I probably have questions I could ask you guys. I'm going to try and think of them, but yes.
So we know that there is some anomaly data in there, which is the red team data, but we're not sure if the only anomaly data there is the red team data.
That's a very good question. Yeah, it's possible. Now, but then it's also possible that whoever released this data somehow vetted all 1.5 billion, but no, that's not very possible. So yeah, there probably is some dodgy things going on there. It is Los Alamos Labs, so I would say that they have incredibly good cybersecurity. But then it's also government, so maybe not. No, I'd say it's probably very good cybersecurity. So you raise a really good point. I was looking. So when I was training this, and I did kind of change the training methodology, so I haven't looked at it since. But I was like plotting the score over time, and I noticed after the main red team event, the benign score was actually going much higher. Like for the benign class, the score was going much higher, kind of peaked up. And so I'm wondering if that's the case, because I'm wondering if it's possible that people they noticed that there was something odd going on, and it's sort of like you interact with the system and it causes a response in that system. So maybe it caused a change in behavior, maybe. But yeah, no, that's a good question. So I don't know, but we do know at least some events. Today, your test set is going to have 50,000 events. 40 of them are anomalous. So that's a very, very skewed distribution. Like last week we were talking about skewed distribution. No. This is a skewed distribution.
Another thing is usually result of this type of detection, you he touched on it a little bit. You don't look at them as a final result, right? So you pass it to other team to investigate on those. There's always should be that, right? If there's anomaly detection or unsupervised or even semi-supervised, like somebody have to look at it. But like now, instead of like 16,000 or a few 100,000 events, they look at 20.
When did that die? After the presentation?
Yeah.
Okay.
The good thing about having red team data, it just shows like your model works.
Yeah.
So the rest of the finding, more or less, there's something iffy about them.
So we're doing, I think it's working now, yeah. We're doing an entirely unsupervised model today, but we are using these red team events as indication, again, that this model works. Yeah.
Elaborate more on the first part, alternate training and sampling.
Yeah, sure. Oh, now in presentation mode. Well, whatever. Man, I really did a lot of animations, didn't I? Okay, so you train the model to convergence on some subset of data, right? So you have your real data, and then you're going to have your negative samples. So some of those samples are going to be classified as anomalous, and then some of them are going to be given a false negative. You want to get rid of all of the ones that are classified as anomalous because the model's already learned them. The false negative ones you want to keep. So then you generate enough data to replace this data that you threw out. You train the model again. So you're giving new challenges for the model. So it's not really going to overfit in that case. I haven't played around with hard negative mining too much, and I would be concerned about overfitting. So it's something that you would have to be very careful with in your validation set to ensure that it's not going to overfit. If you're really just keep mining and mining and mining. But the principle is sound, making sure that you're trying to create the most challenging example possible. It's kind of a dumb method, though. If there was a more intelligent way of saying, like, well, statistically, these are the things that seem to challenge the model the most, maybe it would then bias its sampling towards those. That could be a very interesting application of hard negative mining. I mean, you could do it yourself. Like, just look at the statistics of, like, well, it seems to really have a hard time with this computer or at this time of day or something like that. So let's generate more samples there, and so that it understands. But yeah, that's a good question. Yeah.
I mean, I haven't yet understood the data completely, but this red team flag, this is the one that flags whether this is anomaly or not.
Yeah.
And then, did it come from the original data, or this is something kind of imposed?
No, this came, well, I believe it came from the original data. I didn't impose it. So if the link is there in the talk, and if you go to the link, they post that data there, and they have obviously obfuscated a lot of things. We don't know when this happened. We don't know the processes they used. All of the computers have been anonymized. All of the domains have been anonymized. But the red teaming event, that was the real Los Alamos red team that went in, broke some stuff, stole some things. Probably didn't break some stuff because they're probably very good. Stole some things and gave everybody a headache. But I would believe it's real. Yeah.
Right. My question would be, if you don't have this red team flag, right? How would you treat the self-supervised? How would you treat the original data given the self-supervised learning approach? Like, what is?
How would you judge the quality of the model? Like, how would you be sure that it's performing well?
Honestly, yeah, I didn't get the idea of the self-supervised. Like, if you can maybe elaborate more on it. Like, what is the idea of the self-supervised? Like, how are the labels being created based on a self-supervised method? What is?
Okay, so you are creating the labels yourself. Based on, you take that data, so this is auth login data. Now my original approach was to go row by row because it was, you could be more careful that way, but I've just done a more scattershot approach, which is a lot faster. We've gone from hours into seconds. So you're going to see in the code walkthrough that I pick certain columns that I'm going to vary. So these are some things you want to keep fixed, some things you want to vary. And I sample from the data, the real data. So I'm like, give me 100,000 rows, okay? And then I pick the column that I'm going to change. So say it's the source domain. And then I generate 100,000 random source domain values from the distribution of the source domain. So I look at, for example, okay, this column, for all of the data, this training data, what is the distribution of values for the source domain? Like, how many times is, I don't know, the banana domain being called? How many times is the cherry domain being called? What is that distribution there? And then according to that distribution, or maybe according to a uniform distribution, or however you want to do your sampling, you randomly select those values. And then you just replace all of those values in that column. And then you pick another 100,000 from the training data, and then you replace the next column the same way. So you go through, so you're only changing one value in every 100,000 columns. So you're only focusing on one feature, and then you move on to the next feature, and then on to the next feature, and then on to the next feature. But the idea is that you're creating fake data that's not real. And hopefully, in doing so, you're going to create stuff that is not only like not real, but is also not likely. So there could be a scenario where I log on to the cherry domain at 2 a.m. on a Sunday, even though I always log on to the banana domain. But it's very unlikely. So it's possible, but it's very unlikely. So you're trying to come up with improbable but not impossible kind of scenarios, I guess is the way to say.
I'm just trying to wrap my head around the idea of, okay, so we don't have labels. Is it like we're using unsupervised approach So if you take k-means, there's like the simplest unsupervised learning, right?
Yeah.
So are you kind of somehow coming up with some grouping that somehow will later on serve as my label, or no?
Not really, no. It's more like, it's kind of like unsupervised and self-supervised having a baby together. Sorry, supervised and unsupervised. The word embedding is a really good analogy because I really think it's nice and easy for you to get that if if it is the cat sat on the mat, or I don't know, I'm sorry teacher, I don't have the answer, the dog ate my, you would know the answer is going to be homework. You've heard the story, so you know it's not going to be, I don't know, table. It's not going to be sky. It's not going to be run or hungry or big, small, whatever words that don't fit into that situation. So if you give something that is, this is the correct thing that should be in this situation, and this is the incorrect thing that should be in this situation, and then you have the model decide, it learns over time, well, this is the distribution for the correct thing. This is what normal looks like. I can represent normal. And if it's in a neural network, then you actually end up getting this vector of numbers which you can put into this high dimensional space, and you could then maybe do some projection like PCA or TSNE and then just see, okay, well, these words here all corresponding to finance, they're all very close together. These words here all corresponding to modern art, they're all very close together, and then the art is actually close to literature or music. So you can see that these things cluster together, and there's sort of a hierarchy of clustering. Like really, really specific things are very close together, and then broader topics branching out. So it's the same idea that you're going to get with this data. Is that kind of? Yeah, okay. Yeah, okay, sorry.
So in the continuous case, then how does it work? Because let's say for you do some sort of sampling, how do you know that like what you now sampled is the new sample that you've generated
Is realistic.
It is realistic, but like what if it's benign? Like you can't.
Oh, okay. In the continuous case.
In the continuous case, even.
Oh, that's a tricky question.
Yeah.
So I guess it's like really just in the context of the other values. So say, for example, it was just a normal distribution, and then there was some other values that you were keeping fixed, and the value is over here on this side of the distribution. Maybe just bias it to the other side of the distribution, right? You push it to the other side. Or if it's bimodal, you're saying, well, give me the other mode. You need to know what the distribution looks like beforehand, and you need to be able to say, like, okay, this is what you're sampling from, right? So if you're aware of what the distribution is, then you can probably, and you're keeping the other things fixed, then the safest thing is just to send it to the other direction. And then, yeah, you still don't know, because if it's continuous, what's close and what's not? Because when it's tabular, what I do here is I literally join and I throw out anything that is actually real. You don't. I guess you don't. So maybe this is why I haven't seen anybody do self-supervised learning with continuous variables, and that's why I was warning it. It's not going to be the same thing. It's a really good question. Yeah.
Can you take a question from online?
In 1 second.
Okay.
Yeah.
Oh, so yeah, I'm not too familiar with cybersecurity actually, but so are we assuming that all the events are like independent?
Sorry?
All the roles are kind of like independent. It will be not a situation where when like a few events happens in sequence.
Yeah, exactly. So in this model, we're assuming that the model assumes that they're independent. But you raise a good point that when there's lateral movement by a threat actor, it's like this is a sequence of events, right? And if you get a spike of a weird thing followed by a spike of another weird thing, like, you know, you keep seeing like flags popping up. Those collectively should have a higher score, right? They should, but the model's not going to do that for you. But you could create a model that, you know, did have temporal dynamics to it.
Like RNN or something.
Yeah, but you have to be even more careful there in the negative sampling, because you, like I was saying earlier, you need to make sure that the sequence of negative sample events that you're creating has to make sense. It has to be logical that after this event, this happened. After this event, that happened. You know, that it's not a sequence of the guy stole the money from the safe, then broke in through the front door, and then, I don't know, cased the joint. Like, none of that sequentially makes sense, right? Yeah. Yeah.
So the online question was, so when your system is under attack, how do you prioritize them based on importance? For example, DDoS is happening at the same time a vulnerability is being exploited to access one of your servers.
I'm definitely not the person to ask that question. Maybe Sahar might answer it, although she just left at the right time.
Okay.
So this is sort of, yeah. Can you repeat the question for Sahar, and then we can answer this
I'll
together?
repeat the question.
Sorry.
So the question from online is, when your system is under attack, how do you, for example, you're under multiple types of attack, a DDoS is happening at the same time, a vulnerability is being exploited to access one of your servers. How do you prioritize them based on importance?
First of all, it never happens.
Mm-hmm. Yeah.
Actually, it's always under attack, but it's not passing
It's
the
whether or not they're
controls.
successful, yeah.
I think CIA triad would, like cybersecurity principles, could answer that question. There's this thing called CIA triad. So confidentiality, integrity, and availability. DOS falls under availability.
Yeah.
As per cybersecurity conventions, availability comes after confidentiality. That's just one.
There is a playbook for security operations centers that an incident response. Thank you for.
Yeah, you triage certain events. You're saying.
So incident response and cybersecurity, center, they would prioritize for us. Like we are a data people. We never prioritize anything for anyone. They ask for we are a backup information.
Yeah.
There's a playbook. There are a standard, and based on which system is under attack and which vulnerability, like they prioritize. And usually, like big companies that so many attacks happen in the same time, they have enough resources to like branch out and work to everything.
It depends on what the context of your business is as well. I mean, if you're in the business of, very, very personal customer data, then you really have to do your best to prevent any kind of data exfiltration whatsoever. But if you're in the process of, I don't know, that somehow you're I was going to go with something more critical, like life support systems or something. Okay. But if you've got life support systems and somebody's like doing some attack that is affecting you actually keeping people alive, well, that is clearly more important than protecting somebody's data. So it depends on what the attack is, what your role is, what your company's function is. Yeah.
There are always the standards around that one. Like it's a government probably forces standard as well.
Yeah.
Okay. Thanks.
Yeah. Sorry. Thank you.
This question.
Yeah, that's true. Okay.
So Kat,
Yeah.
today we'll be generating fake data, right?
Yes.
And do you have any like rules on how to generate it? Like what is the best method of generating such fake data?
Yep, that's a very good question. The main rule of thumb, the few ones that I went over would be only vary one value at a time. Some values you should not vary because they would be fixed. Here we're going to more or less vary everything. There are a few that are very highly correlated, which I might not have varied, but it still works. You want to have a large number of negative samples to positive samples. But the main thing, the biggest lesson that I learned that was really painful is make sure that your negative samples are coming from the exact same distribution as your training set. So I'll give you an example of why this was such a pain in my head. I was moving the test set about, right? In the end, the test set actually here is coming from the middle of the distribution because the red team event mainly occurred in the middle of this 60-day window. That's not great because it would be nice if it was at the end or something, but unfortunately, data doesn't accommodate data scientists' needs. So what I have done is I've removed any sense of direction of time. There's still periodicity, so I'm keeping the day of the week and the hour, but you don't know what day it is, like what date. And so I'm able to then extract that test data and put it, from the middle and make that the test data. Problem was that the fake data was being generated from the whole distribution. And so then there is going to be events that only occur in this time window that is not going to be in the training data, right? And so if that's in the training data, if that's in the fake data or the negative samples for the training data, then when you're classifying, it's going to be very easy for the classifier to know this is fake. But on top of that, when it actually comes to the test set and you're putting it in, you're going to have a real problem because anything that was out of distribution is now going to be it's going to be biased towards that. It's going to think, yeah, no, this is all anomalous, and so your whole predicted distribution of values is all heading towards 1, and you really want it towards 0. Everything just ends up getting, it says, oh no, this is all anomalous. So you have to make sure that not only is it coming from the same distribution, but also that you're not overfitting to the training set, because again, anything else that's not then that data is going to seem as anomalous. So really, yeah, sampling is the most important thing, making sure that you're not picking anything out of the distribution, I would say.
You want to cross-validate and test your models based on, you don't want to put much fake data on your test and the cross-validation data, right? Because then you're not optimizing toward what you're gonna see live. You know what I mean? Like, if you put a lot of fake data in your test or your cross-validation, right? And those are cases you're not gonna.
Yeah, it's actually interesting. It actually seems robust against that. So if you train with a ratio of 10 to 1, fake to real, and you plot the predicted values from the validation set, you get this large, values of 1 here, values of 0 here. So very skewed bimodal distribution, mostly 1s. But then when you actually apply the real data, the test data that we've extracted out, you do not get anywhere near that distribution. It's actually robust against that. So it looks more like a normal distribution, kind of centered around 0.4. I wish it was a little bit more to the left. There's probably, if I had more time, I would have maybe optimized it a bit more. But the distribution on the real test data doesn't seem to be too effective. Now, playing around with things like the class weights, playing around with making sure that it's not overfitting, that definitely can bias that distribution towards 1. But it won't have the same structure as the training data does. So it's a fair concern to have, but it's actually okay.
I know, for example, in image recognition or like face detection, they use the Siamese network, right? Where they use a triplet loss. So they have an anchor, a positive, and a negative class, right? And then they use a triplet loss, so they can calculate between the anchor and the positive that this is very small, and the anchor and the negative that this is very large. And so the network will learn that.
It's kind of pushing that away,
exactly,
in here.
So I thought it's kind of the same idea. Somehow.
You could use triplet loss if you want, easily. Right. I just wanted to keep it a little simpler, keep it to cross entropy. But you absolutely could use triplet loss. It's like, okay, 2 real events, 1 fake event.
Yeah. Exactly.
You'd have to be careful in that, I guess. When it's image recognition or facial recognition, it's always 2 images of the same person. So when it comes to an event, what does that mean? What is it like this? It can't be the exact same event. It has to be two events from the same computer or from the same person logging on or same source domain. But yes, you could use the triplet clause. Yeah. Alrighty. Okay, so I'm going to get a glass of water and then we can maybe start the code review before I melt your brains. Question?